All right, welcome to class. With us today, we want to discuss integration by substitution. And this is very important in substitution. So we have been able to do general method. We have been able to do trig function involving trigonometry. So try involving integration. Try and do yourself the honor to watch that so that you follow us. And also, if you must understand how to do integration by part, you should also understand how to differentiate. So it's very important because we're going to be using that thing here. And also, we are always making the x subject of the formula in integration by part or by substitution. We are always making the x subject of the formula. So let's dive in. First thing is this: we are asked to integrate. We're asked to integrate 2x plus 3 all raised to the power of 5. So I have the x here. So what do we do? First task, everything inside here, because it's having power 5, because it's having power 5 now, that is the reason why we are using integration by parts. So first thing we'll do is that we say, let u be everything inside the bracket. So I said we want to make the x subject to the formula. So what do we do first? I will differentiate this. So when I differentiate this with respect to x, I am having business with this, not the constant. So my value here is just 2. So what do we know to do now? I will make the x of the formula now. In making the x of the formula, we are just interchanging. Take this one here, take this one here. That's all. So we say du over 2 will give us the x. That is all. No big deal. Take this one here, bring this 2 down. So we now say, so therefore, the x now will become du over 2. So this is the steps we are taking. Now, what's the next thing we know to do? We will now come back to this point where we say the integral of 2x plus 3 all raised to the power of 5 now. Now, we want to start doing the substitution method now. So what is the idea? We want to remove all the x and change them into u's. That's the concept. We want to remove all the values of x from the beginning and put u there. So let's start. So first, we already know that we said let all of this one be u. Here, 2x plus 3 be u. So I will now say the integral of u now. All these ones now, I have introduced u there. Raised to the power of this 5 times, what is my dx from the beginning? My dx here is du over 2. So I have this over this. Look at it. We have now substituted the value of all the x. We have taken them out and introduced u there. So what's the next thing we do here? If we do this, please, this is not multiplying this. Please, this is a constant, please. So we just have that this one becomes du all over 2. So what are we supposed to do? Please note that if you have a over 2, it's still the same thing as having this times a. It's the same thing. Because when you multiply 1 times a, you are still going to have this back. So from here, we're going to be having 1 and u. Let me take it like this. I will have 1 over 2 times u raised to the power of 5 du. This is what I will be having. This is what I'll be having there. So what do we know to do? From this point, we know that you will bring this one out because we only need u inside the integral sign. Bring this one out. From this point, we'll have that 1 over 2, the integral of u raised to the power of 5 du. So at this point now, we want to integrate. To integrate now, this integral sign and this one goes off. So we say 1 over 2. We now have it like this. So u raised to the power of 5. So when you are integrating, you are adding 1 to it. Whenever you are integrating, you are adding 1. So that number that you are adding 1 to it, bring it down. So plus c. The moment you start integrating, introduce your c is very important. Or at the later end of your answer, introduce c. So from here now, I would now do 1 times this one now. I will have u raised to the power of 6. This one will give me 6. And then all over, this is 6 times 2. Please, 6 times 2, that will give me 12 plus c. But we know that we say let u be 2x plus 3. So let's introduce it back. So we'll now see, anyway, I see you now, put this one. That becomes 2x plus 3 over 12, all raised to the power of 6, please, plus c. This is it. This is how this is done. If you are a JAMB student, if you are an engineering student, if you are planning to write Post-UTME, if you are planning to write GC, further maths in GC, and other calculations, please, this is the best channel for you to belong to. Please do well to subscribe. Tell your friends, your school people, your colleague, your church, the mocks about this channel. This is where you learn a lot. I promise you'll be better at this. Number two question. Number two question. We are told, number 2, that we should find the integral of, so we have 3 over 4x minus 1. Find this integral. Find this integral. So what do we know to do? What is the next thing we know to do? Please, you must also understand indices. If you don't know indices, this becomes a big tax for you. You should understand indices and the way it works. So from here, first thing to do is that I want to remove this 3 out of this point. Remember, we want to take away all the x and introduce u there. So we are doing it step at a time. Remove this 3. If I take this 3 out, I'll have this integral. Because this 3 is there, you cannot just remove this 3 here like this without putting anything. There should be 1 there. So 1 times 3 gives you 3 back here. Don't forget that, please. So that becomes 1 all over 4x minus 1, all raised to this power of 3 dx. So in indices, when I have 1 over a, I can change this divide now into minus by having this. Yes, it was like that in indices. So from this point, I will now have 3, the integral of all of this. So 4x minus 1 here, all raised to the power of minus 3. This one now changes to this. So I have dx. From this point, what do we know to do? We can now say let our u be 4x minus 1. Remember, the next step is to make the x solve the formula. So next year, I will differentiate this with respect to this value. So I will now have only 4. Because this is power 1, just pick 4 alone. Here. From this point now, we are just going to interchange. Take this one here, bring this one here. So we have that the u over 4 will give me dx. That's what we are having. So making the x solve the formula now, this becomes the u over 4. Now at this juncture, we want to make sure that we remove all the x here and here and introduce u. So how do we go about that? From this point, we are now told that to do that sweatlessly, we have that, we'll come back to this point now, where we have that 3, the integral of 4x minus 1, all raised to the power of this dx. So let's start our substitution now. So first, we know that we want to remove all of this x now and put u there. So we know that all of this one we said is u from the beginning. Look at this. We said is u. So I will have that 3, the integral, remove this one now and put u, raised to the power of minus 3, times, we also said that the x is all of this one. So if you put your dx, if you remove your dx and put the u now, you see all the x are no more there. We now have our u. Now the next task here is that we can now multiply this. If we do that, we are having this one. So this cannot multiply this. This is a constant. Just write it like this. So I have the u all over 4. Next task is to bring 1 over 4 out. But we already have 3 here. So you are going to write it like this. 1 over 4, the integral of this value du. Going further, what do I know going further? So this can only affect this. This one can only affect this 3. 3 times 1 is 3 over 4. So I have 3 over 4 there. Then the integral of, please, there is minus here, please. So I have the integral of this value, du. So now let's integrate. Let's integrate. Now, if I'm integrating now, du and the integral sign goes away. So I have 3 over 4 into bracket. So this becomes plus 1. When you are integrating, you are putting plus 1. Don't forget that. So all of this one plus c. So I have that 3 over 4 will give us u raised to the power of 2. And this one is 2 here, plus c. Now, if I open the bracket, I'll have this value all over minus 8, then plus c. But we know that from the beginning, we know that, but we say let u be this value minus 1. That's what we know. So what do you do now? If you see u now, we remove it, and we are going to say minus 3. So I will not put my u again. I'll put this value 1 raised to the power of minus 2 all over 8 here, then plus c. This is how this is done going forward. This is very simple. Please do well to share this page. Do well to introduce this page to your friends, your sisters, your brother, your colleague, your church, the mocks. Do well to do that, because this is important. If you're writing 100, if you're in 100 level already, you must learn integration. If you are doing Post-UTME and other exams, GC, Waec, going further, you must learn how to solve this kind of question. This is it. Next number 3 question. Number 3 question. What do we know to do in number 3 question? So, for the next question, we are having that we should find the integral of cos 7x dx. So how do we remove all of this x now and introduce u there? That is the first thing that should come to your mind. It's very simple. First thing is first, remember what we did in trig function. We said in trig function, normally differentiation now, anytime you have sine, let's say 4x here, we said that everything here is our u. So we say let u be 4x, and then sine therefore becomes u, like this. So it's the same concept we are using here. So we say let u be equals to 7x. That's the concept we are using. Let u be equals to 7x here. Now, what is the next thing we know to do going further? We would now differentiate, because we are looking for the x to be the sort of the formula. So I differentiate this, I'm having just this value out there. So from this point now, interchange. Take this one here, bring this one here. So we know that du over 7 will give us dx. Just take this one up here, bring this one down. That's what I'm just doing. So let's balance it. So we now say the x therefore becomes the u over 7. Now, what then do we know to do? We would now go back into this point now. Look at this point here, where we said that the integral of this dx. So we can now start solving. Now let's start introducing. We want to remove x now and make them and put u there. So we already know that we said let all of this one now, this one be u. So I will now say cos, I'll put my u there, then times, what is my dx? My dx going further is now du all over 7. So this is it. From this point, what then do I know to do? If you do the mass, you are going to have that cos u du all over 7. Remember what I told you, that 7, when it comes out, becomes 1 over 7 there. 1 over 7. So here, I will have here to become 1 over 7, bringing the 7 out of the integral sign. Then I now have cos u du. So to integrate now, I will now have that 1 over 7. If you integrate cos, you are obviously having sine u. This and this goes off. So what then do we now know? Don't forget that when you are integrating, you put your c. But we know that our u is 7x. So I will now have that this value will give us 7x plus c here. This becomes our simple value. This is very simple. It's very simple. Please do well to share this channel. In fact, if you are an 100 level student, you're writing Post-UTME, you are an engineering student, you are lucky to find this channel. Please do well to share this channel and then comment about what we are doing here. Next number, that should be my number 4. That should be my number 4 question. Next number, which is my number 4 question. I have that number 4 here will give us the integral of sine x over 2 dx. So I'm having here sine x. So first thing is first. I already just told you that all of this one becomes our u. So we say let our u becomes x over 2. Let our u becomes x over 2. That means that if I differentiate the u with respect to x here, I'm going to have 1 over 2. If you differentiate from here over 2, if you remove this one, we're having 1 over 2, then times x. We're only differentiating it. If you differentiate it, we are going to have 1 back. 1 times this one will give us this value back. It's very important you note that. So now I want to make the x of the formula. You just interchange. Here we'll cross multiply like this. This is it. This comes here. This comes here. So I will have that 2 du will give us dx here. So my dx here will now give us 2 du. This is it. This is how this is done. Now, what else do we now know to do now? We want to now remove all the values of x and introduce our u there. So what do we do from this point now? We'll go back to this point where we say the integral of sine x over 2 dx here. Now, we already know that all of this one is my u. So I will now say sine, remove this one now and put u times this one. We already know this one here to be 2 du. It's very simple. From this point, what else do we now know to do? Bring these two out of the integral. This will give us sine u du. Very simple. It's very simple. Because when you understand these steps, you can do integration by substitution. So from here, we want to do the integral now. The integral of this one here, I'll have cos u. That is it. Remember, when you are integrating, this and this goes off. So I have this. Put this value here. I'm having minus 2 cos u here. But we know that we say let our u, but recall that we say our u becomes x over 2. So going back to this point now, if I see u there now, I will put x over 2 plus c. This is how you integrate this. It's very simple going further. Next thing on the question here is this, number 5. So we say the integral of minus 5x plus 2 dx. The integral of minus 5x plus 2 dx. So let me take this one off. The integral of minus 5x plus 2 dx. Here. Now, what is the first thing we know to do? Like I told you, if you must enjoy solving integration by substitution, you should understand how differentiation works. This is just the concept we are making use of here. So the first thing we are going to do, remember, whenever we are solving this kind of thing in differentiation, everything at the top becomes our u. So we say let my u becomes 5x plus 2. So if I differentiate this one, the u here, the u with respect to x here, I will just have minus 5. That's all. So I'm having minus 5 here. Interchange this now. Take this one here, take this one here. So we say du becomes 5 to give us dx. So therefore, my dx here will now give us du over 5. This is what I'm having here. So we are now going back to this place now. Put it back where we say the integral of this value, dx here. So we want to substitute now. So anywhere we see all of this one now, all of this value now, we're going to introduce u there. And then anywhere we see this one, we're going to introduce the u over 5 because we want to take away all the x and change them to u. It's very simple. From this point now, what do I do? So I'll bring the integral. We already know that all of this one is my u. That's what we said. Let it be u. So we'll now say that this one becomes becomes u. So I have this. Then times, what is my dx there? My dx now, from this point now, becomes my du over minus 5. This is it. It's very simple going further. So what the next thing we do? We'll multiply this. Please, like I said, this would not affect this. It's a constant. So here now, bring this one out. I have it as this value to give us the integral of this value. So from here, I have this. If you integrate this value, you are still going to have this value back. So and whenever you are integrating the x, du, sorry, this is du and the integral signs goes off. This is what we are having there. So at this juncture, we already know that as soon as you integrate, we are introducing this. But recall that we say let our u be what? Minus 5x plus 2. So we'll take it here. Then we say minus 1 over 5 here. Then this will give us e minus 5. So remove the u now. Remove that u and put all of this one. So plus c. This is how that is done. Thank you for watching. Please do well to put the comment, do well to follow and then share this. Tell people about this channel and please try this for yourself. Try this. Drop your answer in the comment section as we do the following ourselves. Look at this here. We have this. We have 20x plus 4. Here we have this. So by substitution, please, dx. See you in the next class. Bye-bye.